We have a student request to review the binary system. There are only two types of people in the world, those who understand binary and those who don't. After this tutorial, you'll be one who understands binary. Notice that the 1, 0 here I refer to as 2 rather than 10, and we'll see why in this tutorial. First, let's look at the decimal system. If we have a number like this, 27, 305, you can think of this as a cashier register, where to give you this amount of money, I would give you 5 singles, no tens, 3 hundredths, 7 thousandths, and 2 10,000ths. The decimal system is built this way, and if we go to a cashier register here and look at the denominations, we have George Washington on the $1 bill, and let's pretend the next denomination is 10 times that. That's how the decimal system works. That would be your Alexander Hamilton, and then 10 of those would be your Ben Franklin. 10 of those would be a Grover Cleveland, which I've never had in my wallet, and 10 of those would be a Chase. The same Chase that the Chase Manhattan Bank is named after, a $10,000 bill. Well, let's close this and proceed to the binary system, where here the binary system is based on 2 instead of 10. So we start with 1, and we go 2 times 1 is 2, and 2 times 2 is 4, and 2 times 4 is 8, and 2 times 8 is 16. That's how you get the denominations in the binary society. And also, you cannot have more than one of any of these. It's either 0 or 1. You run out of numbers very, very quickly. The binary means 2 numbers, 0 and 1. Decimal is 10 numbers, 0 through 9, it's 10 different digits. So it's easy to go from the binary to decimal because you can simply add these up. That's 116 and 18, that's a 24 total, and 2 more is 26, and this one is a 27. So that represents 27. It's neat to get a handle on the binary system by counting in binary. So for example, if we click this little button here, it has 1, and this would be your 2, 3, this is your 4, and this is your 8, and this is your 16. Remember, you just multiplied by 2. So here we run out of numbers. That's 1. We have to then kick, like you kick over in an odometer, where if you get a 9, you go 1, 0, and you call it 10. Here we run out of numbers very, very quickly. So that would be 2. 1, 0 is 2, as we saw on that shirt. Then if you put the 1 in here, that's 1 plus 2, that's 3. And then here, that's like having 2 9s in decimal. We run out of numbers, so we have to kick here and reset these to 0, and that's your 4. Then that's 5, and that's 6, and that's 7. See, one of each, a 1, a 2, and a 4, that's 7. And then here we have an 8, that's the 8 slot, and then 9, 10, 11, 12, 13, 14, 15, and then that's 16. We put a little space in here, kind of like a comma, so we can see this better. So that's 116, that's it. That's 116 and a 1, that's 17. There's 116 and a 2, it's 18. There's 19, see, 20. Very nice. And that's how the binary system works. That's the binary odometer, see, like that. Somewhat addicting after a while. So here, the hardest thing to do is to go from the decimal system here to the binary. That's the tricky part, see, and that's what we're going to do last here. So say I want to give you $45. How do I do that? Well, this is my cash register in the binary society, and the next one over here to the left would be 64, 2 times 32. So what should I give you if I need to give you $45? Well, I wouldn't give you a $64 bill. That would be too much. So I give you a 32, and then I asked myself the question, how much do I owe you? Well, what's 32 from 45? 13. Oh, you 13. Do I give you 16? No way. Be overpaying you. Now I can give you an 8 because I owe you 13. And if I give you an 8, then I'm down to owing you $5. And then it's easy to see $5 is one $4 bill and one $1 bill and no 2. And then I'm finished. And I can check my result because it's easy to go the other way. This is simply a 32 plus an 8, that's 40. 44, and that's 45. It checks out. So when you want to go from the decimal to the binary, just give the largest amount of money you can without exceeding what you owe the person, and then subtract and proceed like we did, and you're all set. You understand binary.